Welcome to The Explainer. Look around literally any modern lab, read a recent scientific journal, or just casually scroll through tech news, and one thing hits you right away. Artificial intelligence is just absolutely everywhere in the scientific community today. But as we rush to plug these incredibly powerful models into every single stage of research, we kind of need to hit pause. We need to confront a really massive paradox. AI is churning out more output than ever before, but we really have to figure out what it's actually doing to our collective knowledge.
Okay, let's dive right into this. The core question we're unpacking today is this: is AI opening up new science, or is it actually closing it down? I know, it sounds almost completely counterintuitive, doesn't it? I mean, we naturally just assume more computational power automatically equals more discovery. But we seriously have to ask whether these sophisticated tools are acting as a true catalyst for groundbreaking discovery, or if they're just trapping us in a highly efficient, endlessly echoing loop of what we already know.
To really wrap our heads around this dynamic, let's compare two ideas. First up, we have AI's primary superpower, which is interpolating existing data. James Evans, who's a computational social scientist at the University of Chicago, points out that the easiest thing for AI to do right now is take all the data we already have, work out the missing entailments, and just seamlessly fill in the holes. It is fantastic, literally unmatched at standardizing and deduction. But here's the catch. The actual goal of true science isn't just filling in gaps, it's discovering the completely unknown, right? If the entire scientific community relies heavily on an engine designed to perfectly average out our past discoveries, well, we run the very real risk of closing down those unexpected avenues that lead to true scientific breakthroughs. And honestly, this brilliantly illustrates the philosophical knot we find ourselves tied up in. As James Evans so powerfully puts it, there is a Heisenberg uncertainty principle about Gen AI. The moment you can measure the space of ideas is simultaneously the moment someone has generated an agent to intervene. Think about what that actually means for you, or really any researcher out there. If you use a large language model to brainstorm, organize, or refine an idea, you can no longer cleanly separate your own original human thought from the AI's generation. We literally can't tell where our own minds end and the algorithm begins anymore. The observer and the tool, they are permanently blended together. Section 2, the verification crisis, evaluating the black box. So, because human and AI thought are now so deeply intertwined, and because AI can generate just vast amounts of plausible text instantly, the scientific literature is facing an absolute avalanche of verification challenges. Just compare our current verification systems. On one hand, we've got traditional peer review. We all know it, it's slow, it's human-driven, and let's face it, chronically under-resourced. Now compare that to AI-driven generation. This operates incredibly fast at a massive scale and produces this black box output that is mathematically optimized to look highly plausible. Evans notes that trying to use traditional human methods to regulate this high-dimensional AI output is honestly like using stone tools to fight a modern army. Because AI is so incredibly good at dressing up weak science to look completely robust, we are being forced to develop a completely new verification layer. A layer where we actually have to deploy specialized AI to check the AI. Wild, right? So the absolutely crucial point here is understanding the sheer scale of the downstream dangers if we fail to verify this AI-generated science. AI doesn't just generate weak science dressed as strong science, it has the potential to leave undetectable Easter eggs, hallucinations or really subtle, deeply buried errors inside the foundational data itself. Think back to the early 2000s Alzheimer's research landscape. The beta-amyloid hypothesis gained massive traction, but over a decade later, it was discovered that some foundational studies actually contained falsified images. That initial human error unleashed billions of dollars of misguided capital and just years of wasted research. Now imagine an unverified AI system generating those kinds of errors at lightning speed. We could literally be steering entire fields of study straight off a cliff. Section 3. Bicycles of the mind, the cognitive threat. But the systemic threat to institutions and capital, that isn't the only problem. We really have to ask ourselves, what actually happens to the human brain when we continuously offload cognitive heavy lifting to an algorithm? You've likely heard Steve Jobs famously describe computers as bicycles of the mind, incredible tools that effortlessly multiply human physical and mental efficiency. But Evans argues that what we desperately need right now, in the age of generative AI, is a stationary bike of the mind. So what is that? It's an AI tool specifically designed to require intellectual exertion and active engagement from the user, developing their critical taste rather than just completely replacing it. The point here is that we must deliberately build and use AI that makes us sweat intellectually. If we just ask the AI for a polished answer and accept it without critical thought, our cognitive muscles are going to atrophy. We'll lose our fundamental capacity to evaluate what's real and what's just a highly sophisticated hallucination.
Now, what's really fascinating here is how our brains actually react to different types of AI outputs. A recent study revealed that when AI gives humans a perfectly neat, balanced, authoritative answer, human performance actually drops, but their confidence skyrockets. Because the AI sounded so reasonable and so balanced, humans completely offloaded their cognition. They didn't think critically at all, they just blindly trusted it. But, and here's the kicker, when the AI was intentionally tuned to give a biased answer, or one that just felt slightly off, human performance went up, even though their confidence went down. They felt destabilized, so they engaged deeply, scrutinized the output, and ultimately performed way better.
Section 4. Optimizing for surprise. If AI naturally smooths over anomalies and just hands us perfectly average, unsurprising answers, how do we actually advance science? Well, let's trace this philosophical timeline from the American philosopher Charles Sanders Peirce. He beautifully mapped out how learning and discovery actually work. Step 1 is induction. You generalize from observed data. Step 2 is deduction. You infer the specific details from what you already know. Now, AI is absolute magic at these first two steps. It interpolates brilliantly. But true scientific breakthroughs, those happen at step 3, abduction. Abduction is surprise-driven discovery. It happens when you observe something that completely violates your expectations, and you have to make a massive creative leap, often pulling alien concepts from completely different fields just to explain it. AI doesn't do abduction naturally because it is literally programmed to avoid surprise. Think of a scientific body of knowledge, kind of like a vast landscape. The massive center represents the core of the discipline. When you use standard retail AI to search for connections, it safely pulls you right there, into the dense, highly cited average middle. But the remote discoveries, they live out on the tiny fringes, the tails of the distribution. This is exactly where those massive abductive breakthroughs actually lie. To reach those tails, human researchers have to actively and aggressively steer the AI away from its default settings, forcing it out into the weird, surprising fringes of knowledge. The fundamental clash is basically this. Large language models are mathematically designed to minimize perplexity. They're trained on historical data to predict the most likely, least surprising next sequence of words. That is their entire architecture. But true paradigm-shifting science, that maximizes surprise. It is the exact opposite of what an LLM is trying to achieve. A genuinely disruptive scientific paper should actually be incredibly perplexing to an AI that is only trained on the past.
Section 5. Humans at the helm. So with everything we've unpacked, the resolution to our initial paradox becomes pretty clear. AI is absolutely not replacing the human scientist. In fact, it's making human intuition and our natural drive for curiosity more vital than ever before. As Evans warns, it is going to have, by definition, diminishing marginal returns. They're inherently backward-looking. Basically, if we enter a so-called dataless future where scientists just use AI to interpolate past data over and over without ever engaging the real world, scientific progress will eventually just flatline. We desperately still need human scientists to get into the lab, to gather entirely new expectation-violating data from the physical world, and to swing our experimental telescopes toward the very surprises that the algorithms are literally programmed to smooth over.
So I want to leave you with a final, provocative thought to take back to your own desk and your own workflows. Think about this. In your daily use of AI tools, are you merely searching, or are you truly researching? Are you just letting the algorithm pull you comfortably into the average center, or are you sweating intellectually, riding that stationary bike of the mind, and forcing the tool to the outer edges to find something genuinely unexpected? Use these models for sure, but don't let them do the thinking for you. Use them to push past the predictable and seek out true abductive surprise. Thank you so much for joining me on this explainer, and keep questioning everything.